Today we are discussing about the different types of reaction. First portion we have already discussed in the last class. Then now we are going to discuss about decomposition reaction. What is meant by decomposition reaction? That is, something is broken down into simpler units. Simply we can understand like that. That is, one single substance is broken down into smaller pieces. That is called decomposition. Decompose, degrade. We are using this term usually in our daily life. In daily life situation, decomposition of vegetable matter, all these we use, commonly we use the term. In the chemical reaction, decomposition reaction means a substance, a single substance is broken down into small, simpler units. Such reactions are called decomposition reaction. Let us see one reaction here, that is ferrous sulfate. It is a green crystal, light green crystal, very beautiful in color. And this green crystals, when it is taken in a test tube and heated in a boiling tube, we can heat it, and you can see that gradually the color of that solid, that crystals, is changing into a brown color. What is the reason? Because from ferrous sulfate, green color, it is changed into ferric oxide. Ferric oxide is having a brown color, and also along with that we can also have a sharp smell of these two gases. Here sulfur dioxide is formed and sulfur trioxide is also formed along with this. So here you can see that ferrous sulfate is broken down by the help of heat. When it is heated, it is changed into three small different compounds, or three small units are formed from ferrous sulfate. So ferrous sulfate, when heated, it is broken down into three small units called ferric oxide, sulfur dioxide and sulfur trioxide. That is breaking of a single substance into smaller units. Such reactions are called decomposition reaction. So this is an example for decomposition reaction. Even here we can have a question, that is what happens when green crystals are heated. Green crystals of ferrous sulfate is heated in a boiling tube. Usually such questions are asked for the examination. What is your observation? That is, it is gradually changing into brown ferric oxide. So it is, the color is changing. So there is a chemical reaction taking place, and there is the evolution of certain gases having a sharp smell of burning of sulfur. When sulfur is burnt, such gases are evolving from the burning of sulfur. That is, when sulfur burnt, sulfur dioxide is formed, that you know. So here, along with the ferric oxide, there is evolution of gases. They are sulfur dioxide and sulfur trioxide. These two gases are also formed along with this. So here one single substance, ferrous sulfate. This is ferrous sulfate. It is split into three different smaller units called that is ferric oxide, brown in appearance, and sulfur dioxide is a gas, and also sulfur trioxide is also another gas. These are the different units that are obtained by the heating of ferrous sulfate. So this is an example for decomposition reaction. One single substance is broken down into simpler units. Here three simpler units are formed by the heating of ferrous sulfate. So this you can write as an example for decomposition reaction, and also you can have another type of question, write equation showing the decomposition reaction when ferrous sulfate green crystals are heated. For that you have to write this equation and you have to balance. So this is the way in which different types of questions are asked. So in our class we will discuss the question answers also along with our class activities. Here is another example for decomposition reaction, that is the decomposition of calcium carbonate by heating. By heating, when a substance is undergo decomposition, it is called thermal decomposition. Using heat we are splitting a substance into simpler units. For that we use the term thermal decomposition. Decomposition using heat. Thermal means something is related to the word heat. So here the decomposition is done, that is taking place with the help of heat. That is why it is called thermal decomposition. Calcium carbonate undergo thermal decomposition because it is heated and it is changed into calcium oxide and carbon dioxide. Calcium oxide is quicklime. The chemical name is calcium oxide. Quicklime is the common name. And along with this, one of the products is carbon dioxide. Therefore, carbon dioxide is formed, calcium oxide is formed when calcium carbonate is heated. Here one single substance, calcium carbonate, on heating it is split into two substances, calcium oxide and carbon dioxide. This is also a decomposition reaction, an example for decomposition reaction. And here lead nitrate. Lead nitrate when heated, it is changed into lead oxide and nitrogen dioxide, then oxygen gas. Here, this is a single substance, lead nitrate. When it is heated, it is changed into lead oxide and nitrogen dioxide. This is a brown gas. So what happens? What you can observe is a question that is usually asking for the exam. That is, what happens when lead nitrate crystals are heated? When lead nitrate crystals are heated, you can see the evolution of nitrogen dioxide, which is a brown gas. Brown colored fumes are evolving from the mouth of the test tube. What is the reason for that? Because during the decomposition using heat, this is also a thermal decomposition. Thermal decomposition of lead nitrate give three components. One of the components is nitrogen dioxide, which is having a brown color. That is why we can see the brown evolution of gases from the boiling tube in which we are heating the lead nitrate crystals. From water, we can prepare hydrogen and oxygen by splitting water using electricity. That also we have studied a little bit in the lower classes in your previous 9th standard or 8th standard. You might have studied. And here also this is a decomposition reaction. That is why we are again saying about the decomposition of water. Water is a liquid. Liquid water is taken in a beaker or a plastic mug and placed two electrodes. Carbon rod is taken as electrode. Two electrodes are fixed in the bottom. Then it is connected to a 6-volt battery and there is a switch. And to that water you have to add a little bit of dilute acid, sulfuric acid or hydrochloric acid, like that. Usually dilute sulfuric acid is added, a little bit of sulfuric acid is added, dilute sulfuric acid, to make the water a good conductor of electricity. Then only the water will conduct electricity and electricity will flow through the water very easily and it will split water into hydrogen and oxygen gas. Here water is a liquid. Water liquid is split into hydrogen gas and oxygen gas. Hydrogen gas is collected at cathode. At cathode hydrogen gas is collected. Here two test tubes filled with water is inverted down so that then we can find out, we can see the evolution of the gases here, and also it is collected here in this portion. Here oxygen gas is collected, here hydrogen gas is collected. Because hydrogen gas is evolved from cathode, it is collected here by pushing the water downwards. By the downward displacement of water, here hydrogen gas is collected. Here also oxygen gas is collected. We have placed two test tubes filled with water over the electrodes, these two carbon electrodes, and after that we are passing electric current by using 6-volt battery connected to this apparatus. And when current is passed, it's split, the water split into hydrogen and oxygen, and hydrogen is collected at the cathode and the oxygen is collected at the anode by the downward displacement of water. And then water goes down, and in that place hydrogen fills in this gap, and here oxygen is filled. This is the decomposition reaction. This is an example for decomposition reaction. But here the decomposition takes place with the help of electricity. So this is also, we can say that this is electrolytic decomposition, we can say that. Or we can say that is an electrolysis, we can say that. Using electricity, a chemical reaction has taken place. What is the chemical reaction here? Here the chemical reaction is water split into the components, that is hydrogen and the oxygen. This is a decomposition reaction, and this is taking place with the help of electricity. So it is also called electrolytic decomposition. In the previous examples we have studied about thermal decomposition. Here it is an electrolytic decomposition. What happens when electricity is passed through water, then we can say that it's split into two gases. They are hydrogen and oxygen. What are the write the chemical reaction for that? Such type of questions you can have for the examination, and also using this diagram. Sometimes in the question paper they will give a diagram like this, and you may be asked to write what is here. Sometimes A or B is written, what is A and what is B, and what is the purpose of adding a little bit of dilute sulfuric acid to the water taken in the beaker or mug in which we are conducting the electrolysis or we are conducting the decomposition reaction. What is the purpose of adding dilute sulfuric acid? That question may be you can expect. That is, in order to make water a good conductor of electricity, we are adding a little bit of dilute, small amount of dilute sulfuric acid to the water taken in the beaker for the electrolysis to take place very easily and to make the water a very good conductor of electricity. That is the answer for that question. What are the different gases formed when electricity is passed through water taken or through water? When electricity is passed through water, it's split into two gases, hydrogen and oxygen. It is in the ratio 2:1. Hydrogen is in the larger amount. 2 volume hydrogen and 1 volume oxygen are formed. Here also we can see that here the volume occupied by oxygen is in small quantity, and also it is in, here it is twice, we can see from this portion. It is twice, the hydrogen collected is twice than that of the oxygen collected. That is also, from that also we can have a idea that hydrogen is produced in larger amount, twice that of oxygen. The volume of hydrogen produced is twice than that of the oxygen collected in the test tube. Therefore, this is an example for a decomposition reaction. This is called electrolytic decomposition of water. Next one is decomposition reaction with the help of light. That is also called a photochemical reaction. Photo means light. Using sunlight also we can have a decomposition reaction. That is here silver chloride is a solid, it is white in color, and when it is taken in a watch glass or in a china dish watch glass, then it is kept outside or near the window side we can place, and after 1 hour when you see the white solid silver chloride gradually turn into black silver is formed. So this is a decomposition reaction that is taking place with the help of sunlight. Sunlight split this compound into two, silver and chlorine. Here sunlight is the agent that is helping the decomposition. That is why it is a photochemical reaction. So light is helping the decomposition. In this reaction, light energy is used. In the previous examples, we have used electrical energy, that is electrolytic decomposition, Then thermal energy is used by heating, that is the thermal decomposition. This is photochemical reaction, that is using sunlight or light is used. Light means photochemical reaction. For here silver chloride, white solid, white substance, white precipitate, when it is taken in a china dish or in a watch glass and kept in the direct sunlight or near the window side, after 1 hour or 2 hours you can see that it is changed into black substance, and chlorine is also evolved from that, and it will escape. It is a gas, it will escape, and black silver will remain in the watch glass after 1 or 2 hours. That is because of the decomposition taking place with the help of sunlight. That is, here the sunlight or light energy is helping the decomposition reaction. We have seen a lot of decomposition reaction examples here, and thermal decomposition reaction, some examples we have seen, and electrochemical electrolytic decomposition we have seen, water splitting into hydrogen and oxygen, and here this is the photochemical reaction in which light energy brings about the decomposition reaction. And also silver bromide. When silver bromide is similarly, this is a similar reaction. Silver bromide, white solid, when kept outside in a watch glass, it is also turned gradually into black solid. That is also due to the decomposition reaction, and bromine gas is also formed along with that. These two are similar type of reactions. These two are examples for decomposition reaction with the help of sunlight. And this reaction is used in black and white photographic films. You know, in photographic films, this type of chemical reaction is taking place. Then we have discussed about different types of decomposition reaction. Decomposition with the help of heat, with the help of electricity, with the help of light. All this you have a number of questions from this topic, and study well, and then write the equations, and you may be asked to write the equation for certain reaction. They will give the word equation and they will give the wordings, and you have to write the equation by changing that wordings into this form, chemical reaction or chemical equation form. And you may have to balance the equation. Such questions can be asked for the examination, and that color changes also you have to study very well under this portion. Here I will give you an example. Here what is the change taking place when silver bromide, white solid, is kept outside in the sunlight? Then you have to write it is gradually turning into black solid, silver is formed. So what is formed there? Write the chemical equation. Such questions you can have for the examination. So on this portion you study very well, and share the video and subscribe the channel. Thank you.